All right, welcome everybody to the deep dive. Today we're going to be really getting into the nuts and bolts of how to get data from the web, specifically by using something called proxy rotation in Python.
Sounds a little bit technical.
Yeah, it sounds very technical, but if you're doing any kind of browser automation or, pulling data from websites, this is something that you've probably encountered. You're trying to get information and suddenly you hit a wall,
A wall? Yeah.
you get blocked, you
Yeah.
can't get the data, and you're kind of stuck.
Right. And it's frustrating, especially when you're trying to do this at scale, right? Like, imagine you're trying to collect data from, thousands or even millions of web pages.
And I think a lot of people don't realize, I was reading that something like 65% of large web scraping projects, they completely fail because they don't have a good way of managing their proxies.
Wow, that's a huge number, 65%.
Yeah, it's a lot more common than you might think.
So clearly, this is a very important topic.
It's really important, yeah. So we've got this really awesome guide that we're going to be diving into today, and our goal is to really understand the fundamentals of how to build a system that can handle millions of requests without getting blocked.
So we're talking about robust proxy rotation?
Exactly. Robust proxy rotation, yeah.
And not just about, changing your IP address randomly.
No. It's much more sophisticated than that.
We're going to get into the architecture, how to choose the right proxies, the monitoring, the security, all the essential ingredients that make a system reliable.
Yeah, the things that separate the pros from, well, the people who get blocked.
Exactly.
So let's jump in. Right off the bat, this guide talks about something called cloud-native proxy management.
Right.
Now, that sounds pretty jargony.
It does sound a bit like tech speak.
What does that actually mean in plain English, for someone who's trying to get data from the web?
Well, the shift here is moving away from static lists of proxies that you might have had in the past to these more dynamic and scalable systems that live in the cloud. And the cloud offers some real advantages here. Think about scalability. You can easily adjust your proxy pool size based on your needs.
Oh, so if you suddenly need a lot more, you can just spin them up.
Exactly, or scale them down if you need to save resources. And then there's reliability. The cloud makes it easier to handle failures and recover quickly, ensuring your scraping operations don't grind to a halt.
So this cloud-native approach, I'm seeing some Python code in this guide, a cloud proxy manager class.
Right, that's a great illustration.
And there are all these other things, Asyncio, typing, datetime, Aridus, iometer. It's a lot to unpack.
It can be overwhelming, but each piece serves a purpose. For instance, Asyncio is all about handling many requests at the same time, efficiently making your scraper much faster.
So it can do multiple things at once.
Exactly.
I'm seeing Redis mentioned a lot too.
Redis. That's our workhorse for managing the proxies.
Okay, but what does it actually do?
Think of Redis as a super fast in-memory database where we store and manage our pool of proxies. The regional proxy pool class, which the Cloud Proxy Manager uses, relies heavily on Redis to keep things organized and quick.
So it's like a really efficient storage system.
Exactly. When you need a proxy, it fetches one from Redis in a flash. And there's this neat command, rpol push, that's used in the getProxy method. It grabs a proxy from the pool and simultaneously moves it to a temporary holding area, ensuring no two requests accidentally end up with the same proxy.
So it prevents conflicts.
Exactly, like a well-managed library checkout system.
And I'm also seeing regional pools. Why would you want to organize proxies by region?
This ties back to how websites work. Many websites show different content or block access based on where you're connecting from.
Oh, right. Like some streaming services only work in certain countries.
Exactly. By having regional pools of proxies, you can make your requests look like they're coming from those specific regions.
So you can get around those restrictions.
In a way, yes. The getProxy method even tries to pick a proxy from the most relevant region based on the website you're targeting, making your requests look as natural as possible.
So you're not just randomly grabbing any proxy. You're being strategic.
Absolutely. It's about blending in.
Now, this is where it gets really interesting. The guide starts talking about advanced proxy selection, and it even mentions using machine learning to boost success rates. They're quoting a Stanford study from 2024 that claims up to a 45% improvement.
Machine learning is becoming a game changer in proxy management.
It sounds super futuristic.
It might, but the idea is pretty intuitive. Instead of picking proxies randomly or based on simple rules, you can train a model to predict which proxy is most likely to succeed for a given request.
So it's like having a proxy expert that's constantly learning and improving.
Exactly. The ML proxy selector class they show uses a random forest classifier to do just that.
Okay, so how does this machine learning thingy actually know which proxy to pick?
That's a great question. It all comes down to the data you feed it. The xstrike features method in the code gives us some clues.
Okay.
It looks at things like a proxy's past success rate,
Yeah.
how quickly it usually responds, how many recent failures it's had, even how geographically close it is to the target website.
It analyzes all of that.
All of that and more. By learning from this historical data, the model can identify patterns and make smarter choices about which proxy is most likely to work.
It's almost like it develops an intuition for which proxies are reliable.
That's a great way to put it.
But even with the best proxy selection, things can still go wrong, right?
Yeah.
So that's where performance monitoring comes in. I'm seeing some industry benchmarks here.
Monitoring is crucial. You need to know how your system is performing and be able to spot issues before they become major problems.
So what are we aiming for? What are the numbers we should be looking at?
Well, based on the 2024 benchmarks, a well-tuned proxy rotation setup should be achieving success rates above 95%.
So 95% of your requests should be going through without a hitch.
Exactly. Average response times, ideally under 2 seconds. You don't want your scraper to get bogged down. And your proxy utilization should be somewhere between 60% and 80%, meaning your proxies are being used effectively, but not overloaded.
Those are good targets to aim for. And the metrics collector class, that's what's keeping track of all this data, right?
Exactly. It diligently logs details like the timestamp of each request, which proxy was used, whether it was successful, the response time, even the status code, and which website you were trying to access.
It's like a detailed logbook of your scraping activity.
Absolutely. And having this data allows you to analyze trends, identify bottlenecks, and optimize your system for better performance.
Makes sense. Now, something I hadn't really thought about is the security side of things. Managing all these proxies, there must be some security concerns there.
You're absolutely right. When you're routing your web requests through potentially numerous third-party servers, security is paramount. The guide talks about a secure proxy manager class that specifically addresses this.
Okay, how does it work?
It uses encryption, specifically a library called Fernet, to protect sensitive information like proxy usernames and passwords.
So even if someone got access to your proxy data, it would be scrambled.
Precisely. They also mention an audit logger, which keeps track of who accessed which proxy and when, providing an audit trail for both security and compliance purposes.
Yeah, that makes a lot of sense. So what happens when a request fails? You can't just give up, right? I'm seeing this resilient request handling section.
Failing gracefully is crucial. Resilient request handling is all about designing your system to handle failures and recover from them smoothly.
So it's like having a backup plan.
Exactly. The Resilient Requester class in the guide uses a proxy manager to get fresh proxies and something called an exponential backoff retry strategy.
Exponential backoff, what's that?
If a request fails, instead of immediately retrying, it waits a bit, then retries. If it fails again, it waits a little longer, and so on, up to a maximum limit.
So it's not just hammering the website over and over. It's being a bit more polite.
Exactly. This prevents overloading the target server and gives the proxy a chance to recover or be replaced.
I'm guessing this is really important for avoiding being detected and blocked.
Absolutely. The process involves getting a proxy, making the web request, using a library like AOTTP, catching any errors, marking the proxy as potentially failed, and then applying the backoff before trying again.
It's a whole system for handling those tricky situations.
Precisely.
So we've covered a lot of the technical stuff, but how does this actually play out in the real world? The guide has a couple of case studies. One is an e-commerce price monitoring system.
That's a great example of how these techniques can be applied at scale. They were tracking the prices of 50,000 products every day.
50,000, that's a lot of products.
It is, and it translates to roughly 5 million web requests per day.
Wow, that's a lot of requests.
They implemented a robust proxy rotation system and achieved a 99.8% success rate.
So they were getting the data almost all the time.
And not only that, they saw a 60% reduction in their proxy costs.
So they were saving money and getting better data.
Exactly. And their pricing data was 45% fresher, meaning they had more up-to-date information.
That's a real business advantage.
It shows that investing in a solid proxy infrastructure isn't just about avoiding blocks. It can lead to real, tangible benefit.
Okay, and then the other example was a global market research platform. That sounds like a different kind of challenge.
It is. Their main issue was dealing with the varied rules and potential blocks in over 100 countries.
Oh, right, because different countries have different regulations and things.
Exactly. Using a sophisticated proxy system, they achieved a 97% success rate across all those regions.
So they were able to gather data globally without getting blocked.
And they saw a 75% reduction in blocked requests.
That's a big improvement.
It really highlights the power of having proxies in the specific regions you need and being able to adapt to different requirements in real time.
It makes you realize how important this is for anyone who's working with data from different parts of the world.
Yeah.
Now, the guide also talks about best practices and community perspectives. What are some of the key takeaways there?
For managing your proxy pool, they emphasize having a pool size that's significantly larger than your concurrent requests.
So don't be stingy with your proxies.
Exactly. Regularly check the health of your proxies, remove any that are underperforming, and rotate them based on success rate and usage.
So it's not just a set it and forget it kind of thing.
And no, it requires active management. For error handling, they suggest using circuit breakers, which temporarily stop using failing proxies.
So it's like a safety switch.
Exactly. They also reinforce the exponential backoff strategy and emphasize keeping detailed logs of errors for troubleshooting.
Good logging is essential for any complex system.
Absolutely.
And what about the community? What are people saying about all this?
There's a real sense that proxy rotation is essential for large-scale web scraping, but there are also ethical considerations.
Right, because you don't want to be hammering websites and causing problems.
Yeah, exactly. There are discussions about using cloud-based services for managing proxies, exploring alternatives like VPN switching, and a general recommendation to consider investing in reputable paid proxy services.
So you get what you pay for.
Often, yes. There's a strong emphasis on responsible implementation, respecting website resources, using appropriate delays between requests, and ideally seeking official API access or working with providers for high-volume needs.
So it's about finding that balance between getting the data you need and being a good internet citizen.
Exactly.
So looking ahead, what's next for proxy rotation? The guide mentions some future trends.
The field is constantly evolving. We're likely to see more use of machine learning, not just for picking proxies, but also for predicting potential blocks.
So even smarter systems.
Exactly. Integrating proxy management with edge computing could offer performance boost by bringing proxies closer to target websites.
That makes sense.
We'll probably see more sophisticated techniques for mimicking human behavior, making automated traffic harder to detect.
It's like an arms race between scrapers and anti-scraping measures.
In a way, yes. And with growing concerns about data privacy and security, expect stricter regulations and more advanced technologies around proxy management.
So staying up to date is going to be more important than ever.
Absolutely.
The guide also has some additional resources. What can people find there?
The Google Cloud IP Management Guide is a good resource for understanding how to manage IP addresses at scale in a cloud environment.
Okay, for those working with Google Cloud.
The GitHub proxy rotation projects can provide open source tools and inspiration for building your own systems.
You can see how others are doing it.
And the IOTTP documentation is essential for anyone working with Python, as it covers the asynchronous HTTP client library that's commonly used for making web requests.
So lots of great resources for those who want to dig deeper.
Absolutely.
Well, this has been a really deep dive into the world of proxy rotation. It's clearly a crucial part of web scraping and automation.
It's the foundation for successful data extraction at scale.
So for everyone listening, think about how these strategies and best practices might apply to your own projects.
And here's something to consider. As websites become more sophisticated in their defenses against scraping, how will this balance between data accessibility and website protection evolve?
It's a question that's going to become even more important in the years to come.
Absolutely.
Thanks for joining us for this deep dive. Until next time.
See you then.